Hello and welcome to the first section of this unit, Unit 12, where we're going to be learning about something called tangent ratios. I think that you guys will enjoy the ease of this section, but first I want to describe once again what a tangent is. And if you guys remember from our last chapter, a tangent is where you have a line that's going to barely touch the circle. It's going to touch the circle in one spot. And if you remember from last chapter, when you have a tangent and a radius touching one another, it creates a 90-degree angle. So we have our radius here, we have our tangent here, and it creates a 90-degree angle. And so all we have to do is complete our triangle, and we basically have a right triangle when we draw that last line. And we're actually going to be using this triangle to help us find angles. And so let me go ahead and redraw this triangle. And I'm going to put in an angle. Let's say that I want to find angle A. Now, when the angle was over here, we would use our circle to help us out. This time, though, we don't have to have a circle in order to figure out the angle. This is how it's going to work. First, I'm going to label a couple of things. I'm going to take the angle, and I'm going to go across from the angle. That side right across from the angle is called the opposite. So I'm going to label that opposite. Of course, we have a hypotenuse in this triangle. That's going to be our purple line. Once again, the hypotenuse is going to be directly across from the right angle. So I'm going to go ahead and label that hypotenuse. Then the last line that we have that's not labeled yet, that one is always going to be called an adjacent side. Adjacent means sitting next to, and so this line is next to the angle that we're dealing with. Now, if I were to change this up, let's say rather than this angle right here, I want to find this angle. Let me go ahead and draw my triangle again. So this time I want to find this angle up here. The hypotenuse is going to stay the same. That never changes. It's always going to be what's across from the right angle. But now, dealing with this angle right here, I'm going to go to the side that's opposite it. That's going to end up changing. Before, the opposite side was the blue side, but now, if I go straight across from this angle, I hit the green side. So I'm going to call that side opposite. And of course, the third side will always be called adjacent, the one that's left over. So start by labeling your hypotenuse, then figuring out the opposite side, and then the last piece will be your adjacent piece. Now, when we're dealing with triangles, we're going to start using a new symbol. It looks like this. It's called a theta. And basically, theta is the angle. It's going to be a new way that we can write the angle. So rather than saying angle A or angle B, we'll end up putting theta in that spot. So we're going to be using that word a lot. Now, the tangent ratio, I'm going to have you guys write this down, and then I'm going to show you how to use it. The tangent ratio goes like this. On your calculator, there's a button that says tan, T-A-N. If you don't have a calculator that has the tan button, then you can go ahead and use the calculator, either an online calculator or the calculator on your computer, and it will have the tan button. But this is the way the ratio goes. Tan of theta equals, it's going to be the opposite leg, just like this triangle up here, the opposite side divided by the adjacent side. And I'm going to do an example of this, but once again, memorize this ratio. Tangent equals opposite divided by adjacent. Now I'm going to show you how to use this equation. I'm going to show you with an example. What I have is a right triangle, and one of the sides is 3.8, the other is 2.9, and the other is 4.78. And this is where theta is right here. And I want to find theta. So I'm going to end up using this equation up here to help me find theta. Now, I'm going to label different parts. For instance, where is my hypotenuse? I got to figure out which one of these numbers is my hypotenuse. And so it's always going to be the one across from the right angle. So there's my hypotenuse. Then I want to figure out where is my opposite side. I'm going to go with theta, and I'm going to draw an arrow across. And the one that's across is going to be my opposite. So I'm going to label that opposite. And then, of course, the third side is always going to be my adjacent. Now from here, I'm just going to use my equation, tan of theta equals the opposite, which is 2.9, divided by the adjacent, which is 3.8. So 2.9 divided by 3.8. If I divide that out, I get 0.76. Now, I want to find theta, so I want to get theta by itself. The way that we do that is we need to get rid of the tan. On your calculator, there will be something called tan to the power of -1. A lot of times you have to hit the second button in order to find that. So if you have a calculator and you can't see the tan with the -1 power, then hit your second button and it will show up. So what I'm going to do is I'm going to plug this into my calculator. I'm going to put tan to -1 and then put 0.176. Some of you might have to put the 0.76 into your calculator first and then hit the tan -1. So some of you might have to go a little backwards on that. But ultimately, if you plug everything in correctly into your calculator, your answer should be 37.23. Last example here, and then you guys can try out the problems that are examples afterwards. But example 2, it says find tan of 45 degrees. This one is super simple. All I have to do is plug tan 45 into my calculator. That's as simple as that. If you plug it in correctly, you should get 1. So if you plug everything in correctly, your answer will be 1. There's not a tan to the -1 power, so you don't have to worry about hitting the second tan. You just have to hit the word tan and put in tan 45 and you'll get 1.